All right, guys, going to do it again. We're taking a look at the programming exercises for Chapter 3. There are 5 of them. Of course, I'm not going to give you the answer to all of them, but we're going to take a look at them. So the first one. Write a program that accepts the lengths of 3 sides of a triangle as inputs. And the program should indicate whether it's an equilateral triangle. How do you know it's an equilateral triangle? If the sides are the same, right? So enter the first side, enter the second side, enter the third side. You know how to do that. You're going to call them X, Y, Z, A, B, C, whatever, right? X, A is equal to the double of the input of this into the first side, right? Put our quotes where they need to be, and so on. Got that in the wrong place there. Looks like that's all right. I would do the same for B. I would do the same for C, and then I just need some if statements, right? I need to check to see if A is equal to B and B is equal to C. You don't even need to check to see if A is equal to C, because if A is equal to B and B is equal to C, then according to the transitive property or some math term that I don't remember, then you know that A is equal to C, right? And you know how to write that. If A is equal to B and B is equal to C, then you're going to print the triangle is equilateral, right? That's how you do that one. Of course, you have to print the opposite too, right? You know, the triangle is not equilateral. If it's not, yeah. So you just tack on your else clause, and then you're good with that. Now, when you're ready to run it, when you want to try it out, you click on tasks. And then you click run checks. Now, of course, I don't have the right solution, so it's going to give me grief, right? 0 of 2 checks passed. That's all right. All right, let's take a look at the next one. Write a program that accepts the 3 sides of a triangle as input. It should indicate whether or not it's a right triangle. All right, so how do you know if it's a right triangle? Use a Pythagorean theorem. Pythagorean theorem says that the square of one side equals the sum of the squares of the other 2 sides. So after you ask for A, right, and you ask for B, and you ask for C, whatever. I'm going to use the values that they did, right? 3, 4, and 5. And let's just check it out in our head, right? A squared is 9, B squared is 16, A squared plus B squared is 25. You take the square root of that and you get 5. So we could just check it out, right? If A to the power of 2 plus B to the power of 2 is equal to C to the power of 2, then it's a right triangle. And we'd want to print that out. Then you need to check the other possibilities, right? So elif, because you might need to put B and C and A, right? Because they might be in a different order than we were expecting. If B star star 2 plus C star star 2 is equal to A star star 2, then you would print your message, right? And then you would need to check again, right? If A star star 2 plus C star star 2 equals B, right? Just got to juggle the parameters around. There's 3 different possibilities. And after you've checked all of those three states, then the final else would be the triangle is not a right triangle. Take a look at the next one. This one's slightly longer. A standard science experiment is to drop a ball and see how high it bounces. Once the bounciness of the ball has been determined, the ratio gives a bounciness index. So what does that mean? Let's see if I can get a drawing tool going on here. So you drop a ball, right? It goes down and then it comes back up. And say it was 10 feet from here to here and it bounced back up 5, right? Then it has a bounce index of 50% or 0.5, right? 0.5 over 10, excuse me, 5 over 10 is 0.5. And then the next time it bounces, it's gonna go 0.25, right? See that? It went 10 down and then 5 up. And then it went 5 down and 0.25 up. And then the next time it's gonna go 0.25 down and 1.25 up. You see what it's doing. It's halving it each time, right? So if a ball is dropped from a height of 10 feet and it bounces 6 feet, that's a index of 0.6. And it goes 16 feet, right? Goes down 10 and back up 6. Because 10 times 0.6 is equal to 6. And that's after one bounce. And then for the second bounce, it's going to go back down 6, right? And then it's going to come back up 3.6. How do I know it's 3.6? Because this was 10 times 0.6 is equal to 6, right? And this is 6 times 0.6 is equal to 3.6. So this is after 2 bounces, right? 1 bounce, 2 bounces. After 1 bounce, it's gone 10 plus 6 is 16 feet. After 2 bounces, we have gone an extra 6 feet and then 3.6 back up. So that's 9.6. We'd have to add that to that. And that's like 25.6, something like that. And so on, right? The next time it would go back down that 3.6 and then up a little less. So you can see how it's working. After 1 bounce, down and up. Second bounce, down and up. The down distance and then the up distance is the index times that down distance. And then the same thing. So if the ball were going to continue to bounce, it'd go 10 plus 6 plus 6.3%, 0.6 is 25.6. And then we keep going, right? So we can do something like that, right? You know, the number of bounces, we'd ask them for the number of bounces, right? It'd be an input statement, but let's just say 2 to begin with, right? Well, here, let's use their example, right? It's supposed to bounce 3 times, starting off at 25 and 0.5, right? So the number of bounces is 3, right? And the height is 25, and the index is 0.25. And of course, we need to ask for all that stuff. And then you're just going to kind of use a loop, huh? For X in range, the number of bounces, right? And so for each bounce, it goes the height And then the height is modified by the index and it goes that far again, right? So we need some kind of variable to hold the total, right? And so the total increases by the height of the bounce, but then the bounce gets modified, right? Height times equals the index. And then we add that on to the height again, because this is the downward bounce and this is the upward bounce, right? I pretty much think that's the entire answer there. That was supposed to be plus equals. I guess we should print it out, see if we get the same thing they did, right? Print the total. Didn't really want to give you the whole answer, but that's okay. Let's see. And again, that was supposed to be total plus equals height. I don't know where the period came from. All right, try it again. All right, so that matched their answer. So that looks pretty good to me. Hope you get the idea, going down and then back up. I'd rather you be able to program it than just look at my equations. I went too far in that one and gave you the whole answer. Look at the next one. I think this is the one about calculating approximating pi. Come on. All right, so the value of pi over 4 is equal to this series, right? 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 and so on. Well, the first thing you just need to figure out is how to generate these numbers, right? How do I get from 1 to 3 to 5 to 7 and so on? And so if I'm doing one iteration, I want it to equal 1. If I'm doing 2 iterations, I want it to equal 3. If I'm doing 3 iterations, I want it to equal 5. So 1 goes to 1, 2 is supposed to go to 3, 3 is supposed to go to 5, 4 is supposed to go to 7. So what is that? I think maybe it's 2 times this number minus 1, right? 1, 3, 5, 7, whatever. So that little number, that denominator, is going to be equal to 2x minus 1, where x is equal to which iteration we're on. So like if you were going to check this for 10 times, right? For x in range 10, right? I'm going to call it the denominator, the d, right? Is just equal to 2x, 2 times x minus 1. And then the numerator is always 1, so that's easy, right? And so the value that you're going to add or subtract is equal to 1 over d. Let's just print that out and see what it looks like. All right, print. F quote 1 over curly brace d end curly brace equals curly brace value end curly brace end quote in parentheses, like that. Hope that works. Let's try it out. All right, and so 1 over negative 1 is 0.5. I'm not sure where that negative 1 came from. Okay. Oh, because when you say x in range, it starts counting as 0, does it not? So you know, if the number of iterations, the number of times to run is 4, then we need to start at 1 and go up to times plus 1, right? Or you could just add 1 to it there. But anyways, I think that'll fix it, right? Because we really want to count 1, 2, 3, and 4. And we do that because our number of times is 4. We could come up with a better word, iterations rather than times, right? Now let's look. Take a look. All right, and so 1 over 1, 1 over 3, 1 over 5, 1 over 7, it's looking good. So you just have to have some value, right? And you just need to, whoops, can't use that variable because that's that, right? You could call it total or pi or something. I don't know what you might want to call it, right? And then pi is plus equal to, you know, that value. Except that's not right. Sometimes it's supposed to be positive and sometimes it's supposed to be negative. So you're going to need to figure out a way of making it add and then subtract, and then add and then subtract, and then add and then subtract. And so I can give you some hints, right? One way is that you could check to see if x is positive or negative. Excuse me, even or odd. How do you check to see if something is even or odd, right? If x mod 2 is equal to 0, then print even, right? Else colon print odd. And if it's even, you're going to do one thing, and if it's odd, you're going to do the other. So if it's odd, take a look here. If it's odd, you want it to add, right? Because like 1 over 5, we added it, and 1 over 1, we added it. But if it's even, you want to subtract. You're not going to just do pi plus equals value each time. You're going to do pi plus equals value here, right? Pi plus equals value there. But if you're supposed to be subtracting, you're going to do pi minus equals value there. And then you just need to remember that after the loop is done, totally unindented, you're going to have to multiply pi times 4 because this formula gives you 1/4 of the total value, really. So you're going to need to, after the whole thing is done, completely, you know, unindented, pi times equals 4, whatever. All right, that should be enough to get you going on that one. Any more? One more. Let's take a look at 3-7. Teachers in most school districts are paid on a schedule that provides a salary based on their years of teaching experience. They might be paid $30,000 the first year, and then for each year, for up to 10 years, they get a 2% increase. Write a program that displays in tabular format for teachers in the school district. We need to ask for the starting salary, the annual percentage increase, and the number of years. All right, so really, that's not going to be too hard, right? You're going to start at a certain value, and then you're going to add a certain percentage each year. Why don't we just work on making it in this pretty format, right? So after we've done all of our input, we're going to need to print that value. And you saw what I did. I just copied it, right? Then we're going to need to print a row of dashes underneath that. And then we need some variable that's going to go, you know, and print that. So we need something there and something there. We need some counter. I'm just going to do for x in range 1, 11. Instead, you're probably going to ask, right? the number of years. You need to ask that. And then, you know, you're going to have to do the 2% increase and all that. And I'm not going to actually put the formula in here, but I will do num years here, right? Plus 1. And so here's one of the variables that we got. Num years is equal to 10, right? And so we're going to go from 1 up to, but not including 11. So that's 10. And then we need to print this out with a couple of spaces. And then we need to print this out. So this is supposed to occupy 2 spaces, it looks like, right? And then this is going to occupy a certain other number of after that. I can't quite tell how many spaces is there. 1, 2, 3, 4, right? Something like that. Anyways, so let's print formatted place, right? And so we're going to print parentheses x to get that, but we want it to occupy 2 spaces. So we're going to put x colon 2. Please occupy 2 spaces. And then this piece of data, it's equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 spaces wide, right? So whatever this calculation is, right? Y is equal to, you know, right? This is totally wrong. Don't go by this. This is totally wrong. I just want some numbers to print here, right? And so then we're going to print out y, and I've already forgotten how wide it was supposed to be, right? 1, 2, 3, 4, plus 5 more is 9, 10, 11, 12. So it's supposed to be 12 wide, and we want 2 decimal places, right? So 12.2. That's the syntax we need here. X colon 2 to make this one occupy 2 spaces on the screen. And then this one is going to be y colon 12.2, so that y will fill up 12 spaces, 2 of which come after the decimal point. And let's run it and see what it looks like. All right, now that's not cool. Maybe if we stick an F here, it'll look better. Let's try that. Yeah, see, there we go. Now it's lined up right. Now to me, it should have one more dash and stuff, but I did it exactly the way they did. If I was doing this for my own sake, I would add an extra dash there, right, and push this over one more. But that matches their output, right? And so you just need to calculate this value correctly. You need to calculate how much to increase it by, and then use that as your next new value, right? So I'm not going to give you more help on that, but if you get stuck, you can always text me, okay? All right, I think that's the last one. Looks like it. All right, hope this helps. And then the real lecture, this week's lecture, one of the two, is coming up soon. So let's stop this one here.